So, okay, now you get an idea like what TensorBoard looks like. Okay, then we will talk a little bit about like name scopes and some like detail about like name scopes like using redo, okay, in TensorFlow, okay, and then we can use TensorBoard to show you the differences between these approaches, okay. So when dealing with more complex models, okay, for example, neural networks, okay, the graph can easily become cluttered with thousands of nodes because like in neural network, okay, normally each layer, okay, is separated by layers. And each layer may contain like hundreds of nodes, okay. So you know, you are going to have like as I said, like even thousands of nodes. It's not very uncommon, okay. So the graph can be, you know, if you have thousands of nodes, it's not going to be, you know, easily visualized, okay, because there are too much stuff in there, okay. So to avoid that, you can create name scopes to group related nodes, okay. For example, let's modify the previous code to define an error and the MSE ops within a name scope called loss. Okay, so here, okay, see, we use the with tf.name scope, okay, loss as scope, okay. So underneath this with statement, okay, there's a block which defines error and MSE. Okay, so if you check the name for each operation, okay, here, okay, for the error and the MSE, okay, now I mean each of them will be prefixed with the loss, something like this. Okay, for example, print error.up.name is going to be loss/sum. Okay, and print like MSE up.name is going to be loss/MSE. Okay, so to be exact, okay, if you look at the TensorBoard, it's going to be something like this. Okay, where the loss, okay, the error and MSE will be grouped into this big node loss. Okay, with the abilities such that you can actually expand it to see the detail. Okay. By doing so, I mean, it allows you to have a cleaner computation graph, okay, so that you can focus on the big picture instead of like tiny details. Okay. And in the following, we are going to talk about one thing that is going to be used very commonly in the neural network, which is called the ReLU. Okay, ReLU, of course, is an abbreviation. Its full name is rectified linear unit. Okay, well, it's called linear unit because it's actually it's a linear function, but it's a rectified. What does that rectified mean? Okay, it's something like this. Okay, if f of x equal to x, okay, if you do not see this, it's going to be a very simple linear function, right? Okay, but we use x plus, okay? This x plus actually means that we use max 0 or x. What does that mean? It means when x value is smaller than 0, the f of x will be 0, okay? When x value is greater or equal to 0, f of x is going to be x. Okay, so when x value is greater or equal to 0, basically it's a linear function. Okay, but when the x value is smaller than 0, the function is rectified such that f of x becomes 0. It's going to be something like this. Okay. So this ReLU function, okay, is a unit, okay, which is commonly used in artificial neural networks, okay, which employs a rectifier. Okay, the rectifier is basically that flat, okay, when x is less than 0. Okay, so ReLU computes a linear function of the input and outputs the result if it is positive and 0 otherwise. So and as follows, okay, this h big WB, okay, of x is going to be max x dot w plus b, okay, comma 0, okay, and you can see x dot w is going to be you know, this is going to be a computation. This is going to this b is a scalar value. It's as we have seen that in like a linear equation, this type of like a linear is a scalar value is normally called bias. Okay, it's normally called bias. Okay, and the 0. Okay, and it's max. You can see this one is pretty much similar to this one. Okay, it's the only difference is not like instead of using x, we are using capital X dot w plus b. Okay, so it's a computation. Why? Because okay, the ReLU, okay, is actually going to be, this is unit, right? So what happens that it's going to be something like this one. This is ReLU. Okay, so it's going to take the inputs from many other units. Okay, so each unit input will be represented as as an xi. Okay, maybe this is x1, x2, x3. Okay, Okay, and each input will be will have a weight. Okay, so this is W1, W2, W3, W4. Okay, this is example. Okay, we just use 4 inputs, and the output, okay, is going to be your H, W, B, X. Okay, so to be exact, okay, what happens is that it's going to, this one, okay, ReLU is going to get the inputs from all these inputs, right? So it's going to be like a summation I, okay, well, including this bias. This is B. This is bias. Okay, so you can, it's going to be something like okay, Wi xi plus b, right? That's the result, the ReLU, right? Okay, and as I said, the ReLU, I mean value, if it's smaller than 0, it's going to be 0. If it's greater than 0, it's going to be this value, so it's going to be max. Okay, and you can rewrite this part. Sorry. Yeah, you can rewrite this part as X, this dot is basically inner product. Okay, inner product. X dot W, okay, plus B. Okay? So just want to give you an idea, okay, because you are going to get like a summation from all the inputs. Okay? Of course, not simple summation, it's a weighted summation from all the inputs. Okay. So, so this is like the code. Okay, suppose you want to create a graph that adds the output of 2 redos. This is the code to do the job, okay? But it's quite repetitive. Okay? You can see that. Okay? Number of features is 3. It means like you know, each one has like has 3 features. Okay, so you can see capital X equal to like placeholder. Okay, the shape is none and the number of features, so it's like a variable length, but the second the size of the second dimension is number of features, which is 3. Okay, and this is the represent X. Okay, so W1 basically is like you know, we just assign a random value. Okay, random normal. Okay, it's a random value. Okay, for the weight for each feature. Okay, so that because it's like 3 features, so we just get rid of the first one. Okay, so you get an idea. Okay, we have W1, W2, and W3, right? And then we randomly assign weights to these 3 variables. Okay, for the first redo. Okay, for the second redo, okay, you also have weights. Okay, W2. Okay, and we also use like a normal distribution to randomly assign value to the second set of weights. Okay, well, actually 3 of them. Okay, and the B1 basically is like the input for the sorry, B1 is a bias. Is a bias for the first redo. B2 is the bias for the second redo. Okay, and we set both of them to be 0. Okay, and Z1, Z2 are the result of the X dot omega W plus B. So you can see it's a matrix multiplication of X and the W1. Okay, and after that, okay, we do addition for the resulting value here and the B1. Okay, so this is like this line basically represents this one, this part. Okay, but it's not over. Okay, we call that Z1. Okay, and same thing, we try to compute this value for the second redo. Okay, Z2. And the redo 1 is going to be the maximum value of either Z1 or 0. Redo 2 is going to be the maximum value of either I'm sorry, this is Z2. I made a mistake here. Okay, this is Z2 dot or 0. Okay, so I'm sorry, this is Z2. Okay, so output them, and then we try to add the redo 1 and the redo 2. Okay, and we call it just give a name output. That's it. Let me just make sure I correct that. I thought I had correct that. I mean, last time, but well. So this is the code that computes like 2 redos and add them up. Okay, so you can see there are a lot of like similar statements. Pretty much for each statement we need to repeat it. Okay, so it's like as I said, it's a very repetitive. Okay, but we want to stay dry. What do I mean stay dry? Okay, we don't want to repeat ourselves, right? So we want to simply create a function to build a redo. Okay, so here we can define redo like this. Okay, W shape equal to this one. And basically, we want to do this. We're going to extract this one into a function, and then then we want to use like we set the number of features to be 3, and here we use the placeholder to assign like assign the input. Okay, of course the first dimension is still none. Okay, because we don't know how many input it's going to be. Okay, but of course in the following you can see clearly that we have like how many inputs. Okay, name equal to x. So reloops equal to reloop x. Okay, for I equal to range 5. Okay, so we want to do the output equal to we want to add like 5 of these reloops together. Okay, so now instead of adding 2 reloops, here this piece of code actually adding adds like 5 reloops and output. Okay, so you can see that every time you call this function, okay, here. Okay, here, this is the place you call the reloop function, right? Okay, because this function is called apparently 5 times. Okay, because like every time you call this function, okay, apparently there will be like a node created, okay, for reloop, right? So if you do not think like if you think a little bit deeper, you will think like you will feel like, okay, so all these 5 reloops, they are going to use the same name. Wouldn't there be a name conflict issue? Okay, but in fact, okay, TensorFlow will automatically solve the node name conflict for you. Okay, so when you create a node, okay, TensorFlow checks whether its name already exists. Okay, if it does, it appends an underscore followed by an index to make the name unique. Okay, so the TensorBoard will identify such series and collapse them together to reduce clutter. Okay, so what happens is going to be something like this one. Okay, so the first one is going to be like a reloop, but reloop 0, reloop 1, reloop 2, reloop 3, reloop 4. Okay, and you have bias 1, bias 2, bias 3, bias 4, because after the first bias, every bias when they are created, they found that the bias is already there, so it's going to like find like it's going to use like this rule to create the name. Okay, so it's going to attach the underscore with an additional index to avoid name conflict, basically. Okay, but this looks ugly, right? This looks ugly. Okay, so you can use name scope, okay, to make the graph much cleaner. Okay, how to do that? We can simply move all the content of the reloop function inside a name scope. Okay, in that case, okay, the TensorFlow will give the name scope unique name by appending, okay, underscore 1, underscore 2, and so on. Okay, so okay, you define the reloop function, but under the definition you have like with you define the name scope here. Okay, inside the reloop function definition. So what happens is going to instead of the tensor the computation graph, instead of looking like this, it's going to look like this one. This one looks a little much better, right, than the previous one. Okay, so we also need to talk a little bit about the variable sharing. Okay, if you want to share variable between various components, okay, in your graph, okay, a simple option is to create first and then pass it as a parameter to the function that needed. Okay, an example is like suppose you want to control the reloop threshold. Okay, you may ask, what is reloop threshold? Okay, well, to be exact, okay, let's come back to a reloop definition. This one, okay. This is the original definition of reloop, right? Okay. Actually, this 0 is the threshold. Okay, most of the time the threshold is defined to be 0. Okay, but in some situation, you could use the different threshold. Okay, for example, like 1 or -1, for example. Okay, instead of 0. Okay, so this one, okay, in most cases it's 1, it's 0. Okay, but if you want, you can set it to be a different threshold. Okay, so that's like what the threshold is referring to. Okay, so so suppose you want to control the real threshold. Okay, at this moment, as I said, it's hard coding to be 0. Okay, using a shared threshold variable for all reals. Okay, you just create that variable first and then pass it to the real function. This is a simple approach. Okay, so it's something like this. Okay, define real x and the threshold. Okay, blah blah blah. I think this is very simple. Okay, and the only change all you need to do is like at the last line, but before you do a return, okay, the maximum, okay, instead of just z 0, you use z comma threshold. Okay, that's it. Okay, so all the other codes basically remains the same. Okay, so that's like that's okay. Okay, of course, like before you call this function, you need to create this threshold variable first. Okay, so that you can pass that value to the function. Okay, so it's you pass that to the real function here. Okay, but of course, in this example, you still set it to be 0. Okay, so you actually pass x and 0. So basically, it's going to be the same as the previous code, but of course, it's just show you that you could have used like the other value for that threshold. Okay, so of course this works. Okay, and it works without any problem. Okay, but if there are many shared parameters, okay, in this case, for real, well, there's only one thing we can tweak, which is the threshold. So there's only one parameter that we need to worry about, okay, for parameter passing. But if you have many parameters you need to pass, then it will be very painful to do that. Every time you call a function, okay. So you have different ways to do that. Okay. For example, many people create Python dictionary containing all the variables in their model and pass the dictionary, the whole dictionary, to every function. Okay. Well, what is dictionary? You can kind of think of it. If you know C or C++, but not Python that much, you can sort of imagine that as a kind of like structure. Okay. So you can pass like a whole bunch of stuff, together to function. Okay. But other creates a class for each module. Okay, you can create a real class. Okay, like I'm using class variable to handle the shared parameters. Okay, you can do that. Okay, but this is this is heavyweight. Okay, by the way, Python also allows you to create like classes. Okay, Python is in Python you can also do the OOP. Okay, even though like Python is like just a scripting language, you can create classes and do all this stuff like inheritance, all those stuff like in Python. Okay, but this is heavyweight, so it's not very convenient. Okay. So another option is to set the shared variable as an attribute of the real function upon first call, something like this. Okay, we define the real. Okay, this is function definition. So we under the main scope. Okay, if not has attribute. Okay, if this attribute is not there. Okay, then you set a threshold to be blah 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 like this. Okay, and then you use that. Okay, So by doing that, okay, the idea is to use, so this is one way, okay. Another way, okay, another option, to use get variable function to create a shared variable if it does not exist, or reuse it if it already exists, okay. So this one, okay, this may lead to slightly cleaner and more modular code, okay, than the previous solutions, and is used a lot in TensorFlow, okay. The desired behavior, okay, is controlled by an attribute, a current variable, scope, okay, current variable scope, okay. You can set, the following code will create a variable named reloop threshold, okay, like this, okay, with TF variable scope, okay, reloop, okay, threshold equal to like a TF dot get variable threshold value, okay, shape, okay, because this one is a scalar value, okay, meaning it's like just it's a double, it's a single numerical value, so it's a scalar value, okay. So shape is empty, it's not like it doesn't have any dimension, okay, or you can say it's a scalar value dimension is 0, okay. So initializer, blah, 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 okay. So you can do it this way, okay. So to this last option, okay, in the previous slide, okay, if the variable has already been created by an earlier call, okay, to get variable, okay, the code will raise exception, okay. So this behavior, okay, actually, it's actually a good thing, okay, because it prevents reusing variable by mistakes, okay. So this is actually a good thing to have, okay. So if you want to reuse variable, okay, a lot of times you reuse the variable by mistake, but sometimes you want to reuse the variable name, okay, intentionally, okay. If you want to reuse the variable, okay, you need to explicitly say so by setting the variable scope's reuse attribute to true. So you can actually set a particular like a reuse variable scope, okay, to true, okay. In that case, you don't have to specify the shape or the initializer, okay. So this tier variable scope, okay, you can see that not only it's reloop but also, okay, reuse equal to true. So in here you can define the threshold by using get variable. So if you do that, okay, this code will fetch the existing variable, okay, reloop threshold variable, or raise an exception if it does not exist, or if it was not created using get variable, okay. So alternatively, you can set the reuse attribute to true inside the block by calling the scope reuse variable. Okay, this is example. Okay, so there are a lot of things that allows you to do like to control these things. But for the variable reuse, okay, there are some like limitations. Okay, you need to remember. Okay, once reuse is set to true, okay, it cannot be set back to false within the same block. Okay, and also if you define other variable scope, okay, within a variable scope, you can have another variable scope defined inside that. Okay, if you define variable scope to be true, reuse to be true in certain variable scope, okay, for the variable scope defined inside that variable scope, okay, they will automatically inherit the reuse to be true. Okay, so lastly, only variable created by get variable can be reused this way. Okay, so this is like something you need to remember if you want to mess up with the reuse, like so reloop function that acts as threshold variable without parameter passing, something like this. Define reloop x. Okay, so you can define like okay, variable scope. Okay, reloop reuse to be true. Okay, threshold get variable. Okay, So you reuse existing variable, okay, blah, blah, blah. And you return this one, okay? And here you use the threshold here, okay? So x equal to tf placeholder, blah, blah, okay? With tf variable scope, redo, okay? You create variable, threshold equal to tf dot get variable, threshold shape, okay? Initializer, blah, blah, okay? So here, if you create a threshold variable by using get variable, okay? Then it's going to, this redo function is going to reuse that threshold variable automatically. Okay, so in here, okay, you can just call the redo function, okay, output it, okay, output the result of the redo addition. Okay. Well, in addition, variables created using get variable are always named using the name of their variable scope as a prefix. For example, like this. Okay, because we use redo as our name scope, right? Here. Okay. So, but for all other nodes, including variables created with tf variable, the variable scope acts like the new name scope. Okay. So in particular, if the name scope with identical name was already created, then suffix added to make the name unique. For example, all nodes created in the preceding code, in the code that we have here. Okay? Except the threshold variable have a name prefix with redo 1, okay, to redo 5. Okay? So here. Okay? But the threshold is different, okay, because the threshold, okay, as I said, okay, it was already created, okay, outside of the name scope, okay, outside of name scope, so it was created here, okay. So if you look at the computation graph, the threshold actually appear here instead of inside each node. Okay, if you want to create a threshold variable inside the redo function, if you don't like this, okay, if you don't like this, you want the threshold appear in each redo function, in each redo block, okay, then it's somewhat unfortunate that the threshold variable must be defined outside the redo function, okay, where all the rest of the redo code resides, okay. So to fix this, okay, the following code creates the threshold variable within the redo function upon the first call. Okay, upon the first call, okay, in the first call we will create a redo variable. Then we use that threshold variable in subsequent call. Okay, so now redo function does not have to worry about name scopes or variable sharing. Okay, it just calls get variable, which will create or reuse the threshold variable. Okay, so let me show you. Okay, so the code in the next slide will call redo 5 times, making sure to set reuse to false on the first call and reuse equal to true for the other calls. Okay, so this is the define redo x threshold blah blah blah. Okay, the first time you call it, okay, you can see you create the threshold variable. Okay, blah 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 blah. Okay, and then after that, okay, you can see this is the first time. Where is it? Okay. Okay, with TF, you can see TF variable scope. Okay, reuse. Okay, equal to redo index greater or equal to 1. So if the redo index is greater or equal to 1, the reuse is going to be true. For if the redo index is the first, if it's the first time you call the redo, okay, the index is going to be 0, so reuse is set to be false. Okay, so this one, the first time you call it, okay, you're going to create this threshold. Okay, starting from the second time, you call the reloop, okay, because the variable scope, okay, the reuse is set to true, okay. So you are going to reuse the threshold that it was created in the first call, okay. So everything will be good, okay. So it's going to be something like this, okay. So instead of like, so you have reloop, reloop 1, reloop 2, reloop 3, reloop 4, okay. So well, it looks something like this. 5 reloops, sharing threshold variable. Okay. So that's pretty much about it for the first chapter. Okay. I think you guys have everything needed to work on the homework 1. Okay. So because homework 1, like I think part of the question is to make use of this tensor board. Okay. So you need to know how to use that. Okay. So so that's pretty much about it for the first chapter. So we'll move on to the second chapter. So let's take 10 minutes break. Okay, we'll come back. We'll continue our discussion to the next chapter. Okay.